All right, guys. Sorry about that. We are back with the last section of Chapter 7, which is 7.6, Student Loans and Home Buying. Okay, what do paying for college and paying for a home have in common? Simple, they both cost a lot of money, which means the loans needed to obtain them tend to have much longer terms than loans for cars and other items. That alone makes them different from other types of loans, but there are other issues that make student loans and home loans worth studying separately. So, we'll begin with student loans, a topic of interest to more students today than ever before. Many economists worry that student loan debt could be the root cause of the next great financial crisis. In early 2017, total student loan debt in America was almost $1.3 trillion. It's hard to even imagine how much money that is. But to put it in this way, that's over $4,000 for every man, woman, and child in the United States, regardless of whether they went to college or not. The average college graduate in the class of 2016 left school with over $37,000 in student loan debt. When it comes to credit card debt, the best advice is often don't. But that's not a viable option for college cost. As we pointed out in the chapter opening, the cost of not going to college is far more in the long run than the cost of attending. Okay, so yes, it costs a lot of money, but the reward in the end is greater when you are working a position that you love um, instead of going to a job every day. Okay, so that's the difference between a career and a job. Your career is something that you worked hard to attain, and it's something that you enjoy doing, whereas a job is just something you're going to every day to make ends meet. So that makes student loans a necessary evil for most folks. And if there's one common theme in this chapter, it's that understanding the nuances of the financial transactions you're likely to deal with makes you far less likely to end up in a bad situation. So there are three basic types of loans that most undergraduates might consider. We have the federal loans made by the government, federal loans made by banks or other lenders but guaranteed by the government, and then private loans. Every student's first choice should be the federal loans due to stability. The interest rates are fixed for the life of the loan and are regulated by Congress, so you're unlikely to end up with a nasty surprise somewhere down the line. There are, however, limits to the amount that can be borrowed from one student through financial loan programs, and private loans might be the only alternative for an especially expensive education. Other than the length of the loan, the big difference between student loans and other installment loans is that payments are typically deferred until graduation. Okay, until graduation, meaning you don't have to make payments until after you graduate. This makes perfect sense, as in many cases, students aren't working enough to make the money required to keep up with the payments. So that's a pretty good deal. But it comes with a catch. In some cases, interest will accumulate on your loan while you're in school, even though you're not making any payments. This can increase the principal balance considerably. The long term can vary depending on the amount borrowed, but the standard term is 10 years, with payments deferred until 6 months after graduation. So, interest on student loans is simple interest. The interest accrues only on the principal balance. We've talked about simple interest, and it's not compounding. So, while the student is still in school, the amount of interest that accrues each month remains constant. The interest is calculated using the simplified daily interest formula. All right, I usually don't read all of that, but that was all pretty good information, especially because it pertains to you as a college student. So let's go ahead and jump into our examples. Um, Here is our simplified daily interest formula. To find our annual interest, we're just going to take the principal times the interest rate. This is pretty much just simple interest without the T, and that's only because the T, if it's annual, is 1, which anything times 1 is itself. So they just don't put it there, but it's technically the simple interest rate. The simple interest formula. All right, then we have our daily interest amount, which is the principal balance times the interest rate, which is what we get here, our annual interest, divided by 365.25. Monthly interest amount will be the daily interest amount times the days in month. Okay, so remember we have some days that have 30 days, and we have some months that have 30 days, some months that have 31, and then we have February, which has 28. All right, so if Sonia borrows $6,500 to cover one-time college expenses in a federal student loan program at 6.8% interest, find the monthly interest for 30 and 31-day months So we need to find the monthly interest. To find the monthly interest, we must first find the daily interest amount. Okay, and to find the daily interest amount, we must first find the interest rate. So we're going to end up finding all three of these just to answer the question. Let's start off with that annual interest, which is the principal balance of $6,500 times the interest rate, which is 0.068. Punch that into our calculator. And we get $442. And then, so then our daily interest amount will be that $442 divided by 365.25. Punch that in our calculator. And we get $1.21. Remember, we can round those decimals to the hundredths place because we're talking about money. So we get $1.21 there. And then we need our monthly interest for 30 days and 31 days. So our monthly interest for 30 days will be the daily interest amount of $1.21 times 30. And then the monthly interest for 31 days will be that $1.21 times 31. This gives me 3630, which this would give me 3751. Okay, so now that we found out all this information, we can answer some other questions about it. How much interest will accrue while Sonia is still in school? Okay, assume she starts school in August and graduates in May, 3 years and 9 months later, and payments begin 6 months after graduation. Okay, so this is our annual interest, so this is per year. And then this is our monthly interest for a 30-day month and our monthly interest for a 31-day month. So she starts school in August, graduates in May, 3 years and 9 months later, and the payments begin 6 months after that. So we got 3 full years. Then we have 15 months. I can pull 12 months out of that to make another year. Oh, sorry, 12 months is what I was trying to. 12 months equals a year. So we can say she really won't begin her payments 4 years, and then I still have 3 months left over from that 15 months. 3 months. Now the trick here, okay, is to figure out what months those are. So if she goes August to May, and then her payments begin 6 months later, well, 3 of those months that were taken to do this year, that will be June, July, and August because she ended in May. So those 3 months that I'm taking to be a part of that next year will be June, July, August, which means the 3 months she still needs to pay will be September, October, and November, which are September has 30 days, October has 31 days, and November has 30 days. All right, so now we can do our calculations. Remember, we said it's $442 per year. So we can take 442 times 4, because that's 8 years. Sorry, that's 4 years. I was doing the math and counting at the same time. So that gives us 1768 for the years. And then we have 3 months. But remember, 2 of the months are 30. So we can take that 3630 times 2. And then one of the months is a 31-day month. So that would be 3751. And I can add all of those up. 1768 plus 7260 plus 3751. All right. So how much interest will accrue? $1,878.11 over her course of being in school before she needs to start making payments. All right, here's another one. Max borrows $11,500 for her last 2 years of college, acquiring federal student loans at 6.2% interest. Find the monthly interest for 30 and 31-day months. So remember, our monthly interest requires our daily interest amount, which requires our annual interest. So we need to first figure out what the annual interest is, which is just 11,500 times 0.062. Put that in your calculator. So the annual interest is $713. And then we need to divide that by 365.25. I'm just using the formulas that we had on the other page. So the daily interest is $1.95. And then we need to figure out how much for a 30-day month would be the daily interest times 30. Oh, I can just do it like this. Now that we've already done one, you guys know what's going on. The daily interest times 30, which gives me $58.50. And then the daily interest times 31, or you can just add another $1.95 to it. Either way works. Equals $60.45, because it's another day, another $1.95. Okay. All right, so we found the monthly interest by first finding the daily interest. Now it says find the amount of interest that accrues if she acquires a loan in August and graduates 2 years later, and payments begin 3 months later. So 2 years later would be that 713 times 2, 6214. So in 2 years she accumulated 1,426. Now that was August to August, 2 years later. So she begins her payments 3 months later. So that's September, October, November, that she also has to pay interest on. September is what, 30 days, October 31, November is 30. So we have 230 days, so that's 58.50 times 2, 0.00711, and then 160.45. Okay, and then we're going to add that to her 2 years, which was the 1426. Okay, no, go out. Okay. Oh, did I do the math wrong? My daughter came in here. Hold on. Shh. Okay, please go out for a second. Sorry. All right, so we had the 1426, and then we had the 177.45. Like something's not right here. Okay, 7, 8, 9, 10, 4, 5, 6, 1603.45. Okay, so that will be her interest by the time she has to start paying. All right, so when interest is covered by the government while the borrower is still in school, a student loan is called subsidized. You guys probably know this already. If interest is added to the principal while the borrower is in school, and then the loan is called unsubsidized. When monthly payments begin on a student loan, they're based on the principal balance at that point in time. These payments can be computed using the following formula. All right, so here's a new formula that we need to look at for a 10-year student loan with principal P and interest rate R. Okay, remember we're always going to write our interest rate as a decimal. Okay, and then payments are our payments are the capital R. All right, so we're going to use this formula to answer a few questions. If Sonia borrows $6,500 to cover one-time college expenses in a federal student loan program at 6.8%, find the monthly payment on the loan from example 1 if the term is in 10 years. So example 1 with Sonia, we did a Sonia example. Here it is. So remember we said that she accrued $1,878.11. We'll have to add that to what she borrowed, which was $6,500. So this is her new principal, okay, that we are going to use in this equation. And we are looking for the R. So R equals, and our principal is 8378 times R, our rate, 0.068 over 12, all over 1 minus 1 plus our rate over 12 to the negative 120. Okay. Literally plugging this into our calculator, being careful to, I would put this in just as I see it, and then I would hit enter, and then I would hit the division bar, and then I will put double parentheses around this. Okay, so I'll let you test that out in your calculator, and you should get R equals $96.42. So her payments will be $96.42. All right, believe this is the last one. Max borrows $11,500 for her last 2 years of college, acquiring a federal student loan at 6.2% interest. We did an example like this, and it says find the monthly payment on the loan from that previous problem that we've done if the term is 10 years. So in other words, we are going to use this formula here because remember this is for a 10-year loan. Let's go back to see what that, here it is. Okay, so Max had earned interest of $1,603.45. We're going to add that to Max's principal, which is $11,500. So this is the new principal that we are going to use in our formula, $13,103.45 times 0.062. That's the interest rate over 12, all over 1 minus 1 plus 0.062 over 12, raised to the negative 120. Okay, once again, you plug that into your calculator, being careful about those parentheses, hitting the division sign, and then doing a double parenthesis. And once again, I would hit enter here just so that I can do a fresh line of numbers. And you should get $146.79. Okay. So when interest on a student loan is not paid during college, we say that the interest is capitalized. As we've seen, when interest is capitalized, it adds to the principal balance, resulting in larger payments. When interest is not capitalized, payments must be made during college, but only covering the amount of interest. You guys may have seen that, or you may be doing that. You might only be paying on the interest on your loans right now. Well, nobody should be paying on loans right now per se, but if you were, you would probably be paying on interest on your loans right now. These terms are easy to get mixed up, so you can use this summary as a reference, okay? Go ahead, you guys can read that on your own. I won't bore you with my voice in reading all of that. But that brings us to the end of section 7.6 and the end of chapter 7, which, like I said, I love this chapter because it's definitely a lot of information, but it's a lot of useful information. So I hope that you guys are not just taking this class because you have to take a class, but actually getting something from it. See how we are using this math in our everyday lives. All right, guys, that's all I have for you today, for this video, I should say. I hope everybody is taking notes and writing down any questions, comments, or concerns that they have for me, and making sure